another Leetcode problem 2564 substring XOR queries. So for this example, we are giving a string S, and it is 0 and 1 characters. So basically, this S is going to be a binary string. And we are also giving a 2D integer array queries. So inside of the queries, we're going to use the first and the second. Yeah. So for the ith query, so for example, for the first query, we're going to find the shortest substring of S whose decimal values val yield second, 1 bitwise XOR with first. Yeah, so what is this meaning? We need to find a decimal value. Yeah, and yield second I when bitwise XOR with first. So what does that mean? This is a very straightforward, very confusing, but let's just try to understand the example. Yeah, so for the first query, the substring in range 0, 2. Yeah, so if we know for the first query that's going to be in range from 0 to 2, it is 101, it is 5. Yeah, so this 5 XOR with the first. This 0 is the first. Yeah. So 5 is this 101, and 101. This is 5, and we're gonna XOR the first, and it's gonna equal to the second. Yeah. So we want to find all such substrings. So 101 is a valid substring. So we're gonna return the index. It's gonna be 0 to 2. So this is exactly what we are doing. There are also others. So for example, this is also 101, but yeah, if it is the same value, we're gonna always return the smallest starting index. For example, this is 0. Yeah. So in other words, val XOR first gonna equal to the second. Yeah. Now what do we got? Yeah, so let's also try to check the formula. So val XOR first gonna equal to the second. So this means first XOR second gonna equal to the val. Yeah. So instead of finding this val, because we don't know how to find it, so we're gonna just turn it. So we're gonna use this f XOR, and at the right side s FOR. Yeah, so the first XOR second here gonna equal to the value, because this one gonna equal to a 0. 0 XOR val gonna equal to val. So actually, we can check the val directly. So this val gonna equal to f XOR s. Yeah, the first XOR second. Yeah. So this means for the first query 0, 5. How can we get it? So it's gonna be 0 XOR 5. The first XOR second, it's gonna be 5. And then inside of the binary string, we need to find all the value which is equal to 5. And finally, we're gonna return the smallest index. Yeah. So the answer to the ith query is the add points of the substring left to right, or -1, -1 if no such substring exists. If there are multiple answers, we're gonna choose the one with the minimum left I. So this is exactly what we are doing. So we have 0, 2, and we also have here. So this is 0, 1, 2, 3, 3, 5. Yeah, we have 0, 2, and 3, 5, but definitely we're gonna return 0, 2, because even though they have the same length, it is 5, but we're gonna return the smallest starting index, which is gonna be 0. It's gonna be 0, 2. Yeah. And secondly, for 1, 2, 1 XOR 2, it's gonna be 3, and here it's gonna be 2, 2, 3, index 2, 2, 3. It's gonna be this 1, 1. It's gonna be the substring. Yeah. As you can see it, we can solve this problem directly using the brute force. Yeah. So, but if we use brute force, what are we gonna do? We have to know the queries. So for example, for this query, we need to know a value 5, and which value gonna be 5? Yeah. This means we're gonna use our hash table. So for example, yeah, for this value 5, it's gonna be a k, and inside it's gonna be values. We have 1, 0, 1. So in this example, 5, we're gonna have the index. It's gonna be 0, 2. This is going to be the value. It's going to be a tuple. And we also have something like 3 to 5. This is another one. Yeah, but definitely we need the first one. Yeah. Now let's just try to solve it. So let me prepare a dictionary, default dict, and inside is going to be a list. And let's just check the length of the string, going to be equal to n. And yeah, we need 2 for loops. So let's just try to use the brute force first. Just try to check if we can solve it. So for j, in range from I, let's just use I plus 1 because we need to, yes, because at least we're gonna choose a character. We will not choose an empty string. I plus 1 to n plus 1. Now we're gonna use this dictionary d. Yeah, but we want to turn the value into an integer. So we're gonna use integer of the value. So it's gonna be si to nj. And while we use the int method, it's gonna be, because si to j is gonna be a binary number. Actually, we just need to use a digital number, so we're going to turn it to a digital number. So this is why we're going to use the int si to j with 2, and this is the k, and we're going to append value. So what is we're going to append value? Actually, it's going to be a tuple. So inside of the tuple, I want to I want to use I j minus 1. Yeah, so for example, if we have a 1, so the first it is I equal to 0 and j equal to 1. Yeah, j equal to 1. Actually, we only need to return a 0, 0 instead of 0, 1 because we only need to use one character. It is a binary number 1. Yeah, but this is the first index. Yeah, but we always want to have the smallest distance. Yeah, so the answer is gonna be the minimum smallest distance. If there are multiple answers, we're gonna choose the one with the minimum left. The answer of the ith query is the endpoint of the substring. Yeah, I'm not sure if I need it, but let's just put it like this. Yeah. So what happens for this dictionary? Let me just read it out. And here I will give an empty array. Yeah. I think this is very important. We have to think about we're gonna turn it into a dictionary, and then we're gonna try to solve it. Yeah, if it is possible. So as you can see here, yeah. So for the integer value 1, we have 0, 0, it is 1. It is exactly what we are doing. And we only need to use this 0, 0. There are also some other cases, as you can see, 1, 2. So for 1, 2, it is this is 0, 1. Actually, we don't need it. Yeah, we can always use the shortest distance. So because this one, it is the shortest distance. Yeah, let's just check the yeah, as you can see, it is the shortest substring of S whose decimal values gonna yield decimal values will yield second when bitwise OR with first. So this value XOR first gonna be the second, but it gonna also be the shortest substring. So this means inside we're gonna try to calculate the shortest substring. Yeah, but how can we calculate it? It's gonna be this one, and we're gonna use a distance. It's gonna be j minus 1 minus I plus 1, so it's going to be j minus I. So for the first position, we're going to use a distance. It's going to be j minus I. Actually, it is this one, j minus I minus 1 minus I plus 1. Yeah. So now let's just try to check what is inside the dictionary. Now as you can see, it's going to be a tuple with 3 values, and the first value is going to be the distance. Actually, we need to use the shortest distance, and after the shortest distance, we're gonna use the first starting point. So this means directly we can use a sort. So for kv in d.items, we can sort it. So dk gonna equal to sorted with v with this array. But we just need to use the first value, because for others it doesn't matter. We just need to use the first value. Yeah, so we're gonna choose the first value. So the sorted result and 0. So now let's just check what happens for the dictionary. Now as you can see, yeah, for this distance 1, actually we got the result, and for this distance 2, we got the result, and for this distance 5, for example, this is 5. Because 0 XOR 5, it is going to be 5. And what is our answer? Our answer is 0 to 2. This is exactly what we are doing. And for example, 1 XOR 2, it's going to be 3. And what is the 3? 3 is here, so it's going to be 2 to 3. 2 to 3 is our answer. So this means we can directly solve it. Yeah. So why not? Let's just try to solve it. We're going to prepare our final result. And here we're going to return the result. And let's just check the queries one by one. So for AD, inside the queries, and we're going to use our value. X, it's going to be A, X or B. This is exactly what we are doing. We want to check if this X is inside of the dictionary, what are we going to do? Yeah, we're going to append it. It's going to be a tuple. If it is inside, yeah, we're going to append it. It's going to be in D with X. We're going to choose the, yeah, here we don't need to use a tuple, because if we use array, it is also okay. Yeah, yeah, we just slice from the first value, it's going to be the second and the third value. Yeah, we're going to put it inside the result. Otherwise, the result is going to append a -1. This means it is not possible. Yeah, I think at least it can pass for some testing cases, but let's just try. Yeah, as you can see, it passed. Actually, it passed for some testing cases, like example 1, 2, 3. Yeah, I'm not sure if it can pass for all testing cases, but let's just try. If it didn't work, let's just try to fix it, right? Yeah. Now let me just submit it to check if it works. Yeah, because this is just a brute force problem. From here, everything is just like a medium problem, or easy or medium problem. Yeah, and actually it is just a medium problem. Yeah, now definitely it will not work, but let's just wait. Yeah, because definitely here, this is a ON, this is another ON, it's going to be n squared, and n going to be 10 to the power 4, definitely it didn't work. Normally we should solve the problem by using ON time, but ON time is not possible. We're going to use this n log 10 to the power of 9. Yeah, basically, yeah, we can use this one. Yeah, we can try to use the property of this one, because for the first and second, the maximum value is 10 to the power 9. So this means we don't need to look through the all the binary numbers. It cannot be so long. Maybe 30 is enough. Yeah, instead of 10 to the power of 4. We don't need to check so many different cases, because definitely it is not possible. Because for the first and second, the maximum value is 10 to the power 9. Yeah, so definitely we cannot use that. That is why it didn't work. Yeah. So now we're gonna try to fix it. Yeah, but before that, let's just wait if yeah, at least it can pass for some testing cases or not. So the optimizing idea is that we're gonna try to check the length. So here this is I plus 1, but we will not let it go to the n plus 1 directly, because for the maximum length for the number for this Si and j. Yeah, for our queries, for this Sij, I mean this Sij actually it is just the value of this value x, and a x or b, yeah, cannot be a big number, because the maximum can be 10 to the power 9. So we're gonna control it from here actually. So we're gonna control it minimum of n plus 1, with a value of I plus 30. I think that is enough. at least for us to solve the problem. Yeah. But as you can see here, actually, yeah, we can see that it's going to be time limit exceeded. Here it is set time limit exceeded. Basically, we didn't pass for all testing cases, although I cannot see it, but it is the time limit exceeded. Yeah, so here I optimized a little bit. Now let me just try to submit it again to check if it works. Yeah, at least we passed for some testing cases, but some of them didn't work. Yeah, so here we passed 56 testing cases, and some of them didn't work. Because for some of them here, for this example, it is 0 to 29. Yeah, maybe I'll make it 31 or 32. Let me just try to check if it works. Maybe this number is not big enough. Yeah, now if I increase it to 31, it might work, because this number gonna be equal to 10 to the power 9. Now let me just submit it to check if it works. Yeah, now as you can see, it works. It passed for all testing cases. This is why it works, because this number, maximum number, gonna be 10 to the power 9. We just need to try to check the length of the substring. It can never be more than 30 or 31. So here currently we're gonna use the 30 because this is I plus 1 and this is I plus 31. So definitely the binary string gonna be 30. It is enough for us to solve the problem. Yeah. Let me check if I print out anything. No. Yeah. I think this is a easier way to solve the problem. So normally the time complexity becomes 10 to the power 4 times the 30. Yeah, here we just output the final result. I think that's basically everything about this problem. Thanks for watching. See you next time.